Hello, members. My name is Marcus James. I am Manager of Office and Administrative Services here at ACA. And before we begin the webinar, I wanted to give you a couple of administrative notes. And attendees are in listen-only mode. And we would like you to please put your questions in the questions dialog box. There'll be a Q&A. During about the last 10 to 15 minutes, I'll read the questions off so everyone can hear what those are, and our speaker will answer those. There's also a brief survey at the end, and we would appreciate your feedback. Finally, as we advance slides, you may notice a lag in your local view. It's probably depending on your bandwidth, but if we have an issue with that on our end, we'll definitely chime in and let you know and correct it. And so to tell you about a little bit about today's presenter, I'll hand this over to ACA's Vice President of Government Affairs, Heidi McAuliffe.
Thank you, Marcus. So today we're really thrilled to have Kevin Biller. Kevin Biller is the Director of ChemQuest Powder Coatings Research. He has been developing, commercializing, and manufacturing powder coatings since he began his career in 1978 at the Glidden Paint Company. Kevin served in leadership positions for numerous companies over the years before establishing the Powder Coater Research Group in 2007. Acquired by the ChemQuest Group in 2021, the Powder Coating Research is a center for excellence in powder coating innovation, troubleshooting, and consultation. Kevin holds 4 U.S. patents in industrial coating technology, has delivered numerous papers at global events. He is the author of Ask Joe Powder, a column that appears in numerous publications around the world. He has published over 300 articles on powder coatings, as well as a handbook entitled Powder Coatings, Foundation for the Novice Formulator. Kevin, thank you for being here, and the screen is all yours.
Okay, thanks a lot, Heidi. Appreciate that, that introduction. Got a lot of stuff to cover today. Thank you all for joining on this. It's probably afternoon for some of you, and maybe it's earlier in the day for others. But thanks for joining us. I'm going to talk about low temperature cure powder coatings. And I want to tell you a little bit before I turn off my face. My perspective in technology and powder coatings through the years, I've done a lot of things, manufacturing, commercialization, but my brain works as a formulator. And this presentation I'm going to give you today, it's going to be from the perspective of a formulator. So keep that in mind. I see formulators as the intersection between the scientists and polymer experts and the actual users and applicators of the finished product, and that's where this one fits in. So I'm going to start my presentation right now. Let's see. All right. So I said we had a lot of material to cover, and I'm gonna try and cover these topics with a modest amount of granularity, but I really want to touch on all the different types of technologies and options for what somebody might describe as low temperature cure powder coatings. So you got an idea what we're going to talk about from this agenda. I'm going to try not to just read my slides. I think everybody's capable of reading. So before I get started, I do want to mention ChemQuest. Like Heidi mentioned, ChemQuest acquired the Powder Coating Research Group, which I started in 2007, and it's all about powder coating technology and innovation. ChemQuest is a much bigger enterprise. It's been around for almost as long as I've been in the industry, I mean a little bit longer, but they do everything from business consulting, strategic transformation, operational manufacturing efficiencies. They're your go-to when you're going to consider mergers or acquisitions in the specialty chemical / powder, not powder, coatings and adhesive industry. And the pillar that that I fit into is the technology development. We have laboratories, not only the Powder Coating Research Group in Columbus, Ohio. We also have a very fully outfitted, not only with equipment, but with some really great experts in liquid paint and adhesive technology in South Boston, Virginia. So ChemQuest does have 2 different laboratories that are available to provide services to meet your needs. The technology development, we work with everyone from advanced materials people, scientists, startups, traditional raw material suppliers, powder coating formulators, manufacturers, and certainly end users as well. So if you have any needs in these areas, please feel free to contact me or any of the other ChemQuest people that you may know. Okay, well, let's talk about low temperature cure. And, there's a question, why? And, to a guy like me, maybe it's pretty obvious, but let's talk about why you would want to consider a low temperature cure powder coating. First and foremost, I mean, if you're not using powder coatings already, powder coatings are a pretty awesome option for industrial coating applications. And a list here of, its attributes, no VOCs. Some people say powder coatings have, minimum or, minimum solvent concentrations. Powder coatings have no solvent, no VOCs, which is a big plus. By and large, they're formulated on non-toxic materials. Heavy metals are avoided, and really the philosophy of the powder coating formulator is to avoid any potentially toxic ingredients. So little or no waste stream. The powder coatings are efficient and high performance. Part of the high performance may have to do with the powder coating can be applied at relatively thick films if they need to be, which enhances the barrier properties of the final coating. The sum up of all these different great benefits or attributes is you're getting a darn good coating with excellent overall economics, and that's been fueling the growth of powder coatings since I was a young lad, getting started in the late 70s. But let's talk about low temperature cure. And we talk about low temperature cure, okay, where might be a good application to consider powder coatings that are capable of lower than traditional temperature cure? I've listed 4 different kind of subsets here for your consideration. And I'd like to kind of go through these one by one to give you some ideas of where these things have popped up and where they certainly can be considered if they haven't been introduced. Heat sensitive substrates, and let me talk about pre-assembled parts. And I mentioned pre-assembled parts, and some people like to assemble their items and then apply the coating. And truth be told, back in the 1990s, I was involved with the first UV curable powder coating commercialization installation. And believe it or not, it was a fully assembled electric motor line, a line in eastern part of Oklahoma for an electric motor company where their headquarters was in Fort Smith, Arkansas, right across the border from this one motor plant. But these were 1 horsepower type motors, plus or minus 1 horsepower. And the line was set up for a UV curable powder coating. So certainly pre-assembled parts can be considered. That being said, something that has pneumatic or hydraulic type components to it, and things as simple as shock absorbers, suspension parts, items like that could be considered for a low temperature cure powder coating. Also, assemblies that have not just metal components, but metal plastic assemblies is another opportunity to consider low temperature cure powder coatings, and other things that may have gaskets in them already. They may be subunits or partially assembled. So these are parts that can be considered for lower temperature cure powder coatings. Plastic substrates. I get this question where people say, can you powder coat plastic? And using that word plastic covers a very, very wide variety of materials. These are but a few of the ones that I've had some experience with applying powder coatings to. And determining what type of chemistry, what kind of formulation, what type of cure mechanism would be considered, you kind of have to look at what type of maximum temperature the plastic can endure without deforming. And we do that by looking at the heat deflection temperature. The title of my presentation is, more than just wood, but I'd be remiss not to mention, the different types of wood substrates that can be considered. Some of them are being powder coated today. Certainly medium density fiberboard has been talked about, and powder coatings have been commercialized for applications of medium density fiberboard since the turn of last century, the turn of this century, I should say. But, you can look at high density fiberboards, you can look at wood composites, and even natural woods. Whereas from my experience, the close grain woods have a better opportunity or better possibility of being powder coated successfully. Open grain woods are a little bit too variable, which will make it very difficult. Now, you say powder coating plastic, and if you do something like that, traditional powder coatings are applied electrostatically to a conductive substrate that has a good continuous grounding or earth. So we got to think of, okay, the application process. So how do you deposit a powder coating, a dry powder coating, to a non or not so conductive surface? And I've done extensive work through the years. One of the concepts is we have some heating process at the tip of a spray gun that's propelling powder into a space. People have worked with thermal spray, which basically is putting some type of flame arrangement at the exit of a gun and causing the powder to become molten, and the molten powder is directed towards a surface. Problem with that, it's difficult to control thickness. You might be able to do this with maybe a thick film where the thickness isn't very critical. It's not the best option. Another way of doing it is to preheat the part and then spray. It's called flocking, but to spray the powder onto a hot surface, the powder will melt, fuse, and flow. The problem with that is if you don't have good control over the thermal process, you may have thermal losses on certain parts of, certain areas on the part, and it may make things inconsistent in the application. There's another thing that's been bandied about through the years, and that would be using a conductive primer. And this one, yes, it can be done. The question is, you're asking a powder coating guy to deliver a environmentally friendly, non-VOC type coatings technology, and maybe you have to use a solvent-borne primer. It's kind of contradictory to the whole concept, but it'll work. The other thing you can do is you can put conductivity into the non-conductive species, and this can be done with something as simple as a conductive carbon black pigment, which then the part becomes any color you like as long as it's black. You can put in lower concentrations of something like a carbon nanotubes, but that makes the overall material cost rather expensive. The other kind of clever process is to go outside of the box and use an in-mold process where you're coating the mold and then you're building the part into the coating. Definitely something to be considered, and in some cases has been successful as a commercial process. The one I like is using a simple conductive solution, going way back into coatings technology history. There's a material called Rands Prep, which is basically a solution of a conductive salt that can be applied to the surface. It flashes quickly and provides a nice, even conductive surface. Anyway, these are some possibilities that you can use to make this surface conductive to apply a powder to. Now let's do a little differentiating between low temperature cure and ultra low bake, because that's going to be the rest of the presentation. Low temperature cure is basically reducing the traditional bake temperature of powder coatings, which is going to be somewhere between like 175 to 200 degrees Celsius, by kind of playing with the melt viscosity a little bit, making a minor tweak, and adding more catalyst. And basically, the concept is put more catalyst in. And I think anybody's a fan of Saturday Night Live might know where I'm going with that one. So just adding more catalyst. When we talk about ultra low bake, we're talking about perhaps a different type of cure chemistry, cure mechanism that's going to allow powder coatings to be applied and cured at temperatures below 150 C, maybe getting down into 120, pushing maybe the envelope just below that. And you have two choices, and I'll talk about them, but thermoset and or UV cure. Low temperature cure chemistries, and here we're going to talk about this from a formulator's perspective. I'm going to go through the kind of traditional powder coating chemistries and give you examples of how you would approach formulating a reduced temperature powder coating, powder cure mechanism. Here's a little cheat sheet that shows standard cure of powder coatings are going to be, dwell times of anywhere from maybe 5 to 20 minutes, but traditionally it's going to be kind of in that 15 to 20 minute type dwell time. And the cure temperature is going to range from about 175 to 200 C. Simple adjustments to the binder system can get you down 20 or 30 degrees Celsius lower in temperature. And I'll give you some examples. In these cases, when you see these types of temperatures, often what you're looking at, the driver is a reduction in energy costs as opposed to getting into less traditional substrates. like the ones I mentioned just before. So if we want to look at getting low temperature cure epoxies and that graphic of our friends on Saturday Night Live, look at a slightly lower melt viscosity epoxy and incorporate or increase the catalyst level. In epoxy powder coatings, imidazoles are very common catalysts. They work well. Most of them are solid, and you can do that. You can also get curing agents that are pre-made, that are pre-catalyzed. An example here, some phenolic curing agents where the KD404 is fast cure. The supplier of these curing agents is just putting in a dose of imidazole catalyst to make it cure faster and at a lower temperature. Now, epoxy polyester hybrids, and this is one where our friends at the polyester resin companies have done a nice job of introducing pre-catalyzed, lower melt point, lower melt viscosity type polyesters. You marry those up with a corresponding kind of lower melt viscosity epoxy resin, and you've got something that's going to cure nicely at the 160 degrees Celsius range. The polyester world, curing agents in powder coating world, TGIC or HAA, also known as Primid. Again, the polyester resin people have provided an easy way for you to lower the cure requirements for the finished powder down to 160. This is easy peasy, my friends. Polyurethanes, when you're trying to lower the cure temperature of a polyurethane in powder coatings, urethane curing agents in powder coatings rely on a blocking agent, and basically the suppliers of the diisocyanate curing agents have alternate type blocking agents that are released in that 150 to 160 Celsius, which give you an opportunity to formulate a lower temperature cure urethane at a price, of course. GMA acrylics, it's a smaller representation of the powder coating world. However, it's a high performance. You find GMA acrylics very commonly used for automotive type trim parts, alloy wheels, things like that. But the GMA acrylic resin manufacturers, suppliers have done a really nice job of driving the polymer architecture into a space where you can do a lower temperature cure, lower melt point with their products. All right. Let's talk about the ultra low bake stuff, the stuff that's gonna give you the ability to cure below 150 and maybe kind of sneak up upon that 120 degrees Celsius with some caveats attached to that chemistry. With epoxies, it's a matter of driving the cure down, and basically, you know, with epoxy chemistry, and this is Bissay type epoxies in particular, you've got a homopolymerization route you can do, and again, surprisingly, you can do this with imidazole catalyst, and it works. It's a pretty hot system. You got to be careful, but we can drive the cure temperature down into kind of that lower range of about 125 Celsius. Hybrid, it's kind of the same. It's a similar type proposition. In this case, there's a very low temperature cure, kind of a low T sub G polyester resin that was designed for the powder coating formulator by the polyester supplier. And this is kind of the low, as low as you're going to go with this type of chemistry. TGIC, again, it's a kind of a combination of getting the right rheological behavior at these lower temperatures. So basically you need decent melt point and also a relatively low melt viscosity at this, kind of 130 to 150 degrees C range. And then kind of utilize some clever catalysis. This TBAP type catalysis system seems to work quite well. It's got a little bit of latency, and it's pretty quick at this this lower sub 150 temperature range. GMA acrylics, we can kind of take the lower cure GMA acrylic polymers and use kind of a special curing agent. In this case, well, I can tell you that traditionally GMA acrylics are cured with a diacid, which kind of allows them to be cured between 150 up to maybe 160, 170 C, depending on the polymer and the catalysis. There's a polyanhydride specific curing agent that allows you to drive the cure of these GMA acrylics below the 150 mark, and it works quite well. That curing agent is somewhat crystalline. When we're talking about materials morphology, molecular morphology, usually things aren't 100% crystalline, 100% amorphous. This one's more towards the crystalline side, and it does aid in getting good melt and flow at these lower temperatures. Here's a system that is pretty much just used for low temperature cure applications and powder coatings. It's based on unsaturated polyester, similar that you would see used in a lot of composites, fiberglass reinforced plastics. But you basically use a malleate unsaturated polyester that's been designed to melt and flow at these low temperatures. You cure that with a vinyl ether urethane, which gives you a really nice cross-link density. This vinyl ether urethane is also a relatively crystalline material, and it gives you the opportunity to give you a nice thermoset system that you can use a peroxide catalysis system and kind of make this thing work. It's been available for probably about 15, 20 years, believe it or not. It's some pretty interesting and in what I would say non-traditional chemistry for the powder coating world. Here's one that is still kind of in the starting blocks, and it's a really, really interesting chemistry. It's a product that was designed by Battelle Memorial Institute. They had a project to do a bio-based polyester, well, actually a bio-based polymer specifically designed for powder coatings. They've published this in, I think they may have published in Coatings Tech. I know they've given a presentation at one of the American coating shows a time or two ago. But this stuff is really interesting. It's a 85% bio-based carboxyl polyester. It's with a high, well, it's a long chain diacid that's been developed using, been synthesized using high oleic soybean oil. It's like a C18, C19 type architecture. Anyway, this stuff can cure with TGIC down to about 135 C, and it gives some pretty amazing performance. It's relatively aliphatic. It gives excellent impact resistance, but the one thing that I didn't quite expect out of this project it gives some pretty incredible UV durability as well. And it's probably not as surprising as it should be, because it's a relatively aliphatic polymer. So that's something you can think about. When we're talking about low temperature cure, you know, as a formulator, as a chemist, as a material scientist, it's like, it's fun to develop these things in the laboratory and to do, you know, application studies and things under lab conditions, but introducing it out to the real world, it brings some hurdles that have to be overcome. Extrusion conditions are critical. You've got to be careful you don't put too much heat, too much energy, too much shear into these systems during the powder processing production. So you kind of may have to redesign your extruder somewhat to provide a short dwell time and also, you know, lower temperature, so you don't get advancement during the extrusion process. Storage stability, it's something you got to watch. When you start driving down the melt point, the T sub G, which, you know, you're getting down into the, you're flirting with 50 degrees Celsius as a T sub G. You got to watch your transportation, you got to watch your storage and your application system conditions. So it's just something you got to look at. Thermosets in particular, they may advance in the solid phase if they're exposed to high ambient temperatures. So it's something you really have to pay attention to with handling these types of chemistries. Application, and again, this is where we're driving down the melt behavior of these powder particles. And we have an issue depending on, you know, how your application system is designed. You know, we're propelling a powder air mixture through tubes and a spray apparatus, which there's a certain velocity of the particles. And if you're not careful, if the temperature gets a little too high, you can get impact fusion on the inside of the application equipment, which is definitely a problem. The other thing with thermoset materials, we're really fighting, we're fighting thermodynamics, we're fighting physics. Basically, we're trying not to have any cure until a magical temperature. And so it's like no cure, and then you want it all to happen at once. The real world probably doesn't work this way, so you may have problems with advancement or difficulty getting an adequate low melt viscosity during the cure process to give you the smoothness that you may be trying to achieve. All right, we're going to wind this thing up. We're going to wind things up with a little discussion on UV curable powder coatings. And my experience with UV cure powder coatings goes back to the mid 1990s. And I'm going to say through the years, I've done a lot of work in this area. And I think I might qualify for membership into the UV curable powder coating maniacs society. I'm not sure. I guess I'd have to ask an independent source that question. But if we want to compare it to a thermoset powder coating process, basically powders applied to a substrate with a thermal cure or thermoset powder coating. You heat the substrate, you heat the coating, you kick over the cure mechanism, and you get your melt flow and hardness, and your part's coated. With UV cure powder coatings, you separate the cure mechanism from the heat, basically. You're going to rely on ultraviolet light to get the cure. So basically what you're doing is you're going through the same kind of application process. If it's an unusual substrate, you may have to look at that conductivity question, but you're applying some energy, typically infrared, maybe a combination infrared and convection to get your melt flow, your film formation that can happen quite rapidly. And then you expose that warm temperature film to the right delivery dosage of UV energy, and you got your coated product at a relatively low temperature cure. Here's a picture of it's a UV cure pilot line I used to have in my lab. It's one of our lab technicians. But basically, this was a 60-second flat line infrared, followed by two banks of 600 watt per inch UV cure lamps, emitters. And we did this at, the cure was measured 7 feet per minute around and got complete cure of a nicely formulated UV curable product. So when you look at UV lamps, you don't want to get too much into this, the engineering side of it, but depending on the wavelengths of the lamps is going to kind of dictate how you do your formulating, specifically with free radical cure and the photoinitiators that are excited at the specific wavelengths that these different lamps can deliver. And basically, when we look at this whole concept of which lamps work best, and would borrow this from a page of the liquid UV cure people and technology. Standard mercury works quite well for clear coats. As you get into metallics and pigmented ones, it's better to use photoinitiators and proper pigmentation that allows the excitation of the photoinitiators at relatively higher wavelengths, kind of approaching the visible light range. Powder chemistries, and I'm only going to talk about free radicals. There is a subset of cationic cure. That's for another discussion. We could do that offline. But basically, we're talking about a photoinitiator gets things rolling after you've melted and formed a film of the powder. And you get your chain growth polymerization of your free radical groups. And there's a possibility of oxygen inhibition, although it seems for some reason the polymers and the systems used in powder coatings doesn't seem to be much of a problem. And I'm not exactly sure why. So the chemistries that are available, it's a fairly limited formulator's toolkit. However, there are materials that are available. There are specifically methacrylated polyesters, solid polyesters, solid epoxies. There's a urethane oligomer, which is available. It's you don't have a lot of choices here, though, my friends. But it gives the formulator the opportunity to kind of play with different chemistries in the formulation to get kind of different performance profile of the finished cure. So basically methacrylated solid polymers to build your coating performance. You can also use this kind of the thing I showed, the peroxide cure solid system, solid polymer system based on the malleate and the divinyl ether. That one works. And basically we're doing low T sub G, low melt viscosity type polymers that have these functionalities. Benefits of UV cure, I mentioned it separates the melt from the cure, which you don't have cross-linking in the extruder. You don't have to worry about that. You don't have chemical reaction in transportation or in storage. You have to get that intense UV light to get advancement. It's a relatively small footprint. You can do it all in a pretty small space, a short production line, finishing line, short time frame, low processing temperature, low energy costs, and it really can be a good option for substrates that can't take temperatures beyond, say, 125 to maybe 140, 150 Celsius. The drawbacks, it's line of sight cure, limited selections of raw materials. We got to work on that as an industry. There's a capital expenditure to build a unique new line. Pigmentation is a challenge, but anyone who's formulated UV curable materials, it can be done. Film thickness is something that has to be controlled carefully. Transportation and storage stability are going to be issues with the possibility of sintering if you get above the T sub G of the material. You can't forget material cost. These things cost more than your garden variety materials that you formulate, traditional thermoset powder coatings. So it's something that's part of the package. So if we kind of want to summarize things here, UV cure versus a thermoset ultra low bake. UV cure gives you really that lower temperature, shorter cure time, small footprint. The thing about UV ultra low bake thermosets, they're easy to pigment. The film thickness is not going to be critical. It's relatively low energy use. The equipment's more standard. It's an easier jump to go from traditional standard baked powder coatings to a fast cure or a low temperature cure thermoset. Like I mentioned with the UV cure, it's line of sight, film thickness, physical storage stability. Sometimes you're in a first adopter type situation. With really low temperature thermosets, it's more in the processing of the powder coating through the extrusion process where you really got to watch what you're doing. Future trends, and we're kind of running out of time, my friends. So we're gonna wind this up. A couple of things going on. Just in the last 6 to 9 months, Allnex introduced some interesting kind of non-traditional chemistry for a powder coating system. And this basically, it's malonate type chemistry. It's real Michael addition. I have a reference to the world patent, which was granted, I think it was in November last year. It's some fascinating chemistry. And I'm not saying it's going to change the world, but it's kind of encouraging because it is new. It's kind of cool chemistry. And, for you chemistry nuts out there, it's something to take a look at. I don't believe it's commercial yet, but you contact the people at Allnex and I think they can give you an update. The other thing that I've been seeing more and more and more, powder coatings, these ultra low bake powder coatings in particular, they're starting to filter into composite type parts application, molded plastics, and it's just a matter of getting the industry to make the change and to convince them. And to do this, the most important thing I think I can to leave you with, it's going to take a team effort. It's going to be a collaboration between the raw material suppliers, the powder formulators, the end users, the engineers, and the equipment manufacturers. So low temp curing, it's something that is here to stay. A lot of good things happening. I would recommend people, jump on the bandwagon and get some good minds working on moving this forward. And I think it's going to be a win-win-win for all parts of the supply chain, and eventually, to the ultimate consumer. So, covered a lot of material. I kind of left you guys with about 45 minutes to throw some questions at me. I'm going to turn this over to
Kevin, pardon me, it's Marcus.
yes.
So just a quick announcement for the audience. Again, if you have questions, you can go ahead and put those in the questions dialog box, and we'll get started with the Q&A. So the first one, Kevin, low temperature cure powders seem like a good idea, but do the economics make sense? Specifically, are the material costs significantly higher and the extra processing and handling requirements an added expense?
It's a really good question, Marcus. I know it wasn't your question, but thank you for that question. People from the audience, I don't see these new innovations, these lower temperature capable curing materials supplanting or replacing just your typical garden variety powder coatings. I think this is going to be more for higher end, higher performance type applications. I can see it for new types of like industries. Good example would be like the EV industry is kind of new, and new powder coating chemistries are falling in line to meet those requirements. But this is going to cost more. It's going to take more careful handling. But I think the materials and the advantage of lower temperature cure and the performance is going to justify being introduced to some of these new applications.
All right, thanks, Kevin. Next one, low temperature cure powders have been talked about and promoted since the 1990s. Why isn't there more widespread use?
This is, this could be a long discussion. And I, my experience in the 90s, there was nothing you couldn't do with powder coatings. Like the industry was growing at double-digit rates. We had really nice, fully staffed R&D departments. If you woke up in the morning, you were going to be successful. And I'm talking about sales, formulating, commercial production, whatever. It was just, the sky was the limit in the 90s. And I did an awful lot of work in this area, this space then. Ushering in the new century, so many things happened that were negative towards introducing new technology. There was a recession at the turn of the century. There was a 9/11 thing that just made things kind of crazy. There was, what would you say, outshoring? I don't know if that's the right word, but, finishing was, and manufacturing was being outsourced to faraway places. And it just seemed like things kind of stopped in their tracks. There's another component to this whole discussion, and it's the issue of first adopters. You need someone who is willing to look at something that hasn't been done before. And I've seen in too many applications, too many opportunities where you just didn't have people, they didn't have the nerve to follow through, even if the coating technology looked like it was going to deliver. I've done a lot of UV cure powder formulating in the last 20 years, and it's just first adopter syndrome is a difficult situation. And kind of going hand in hand with that is, there's this kind of wait and see of the different components of the supply chain, where it's like, hey, we've got a few things, try them, see if they work. We're not going to put a lot of our R&D into developing that specific material, that specific polymer or photo initiator or finishing line or engineering. So people are kind of like, it's a chicken or an egg. If you could commercialize some of these things, then we'd have some money to put into further development. And we as formulators are like, if you could formulate a better polymer, we could get more business or more growth. So I think those are kind of part of the dynamics of what's held this back for the last two and a half decades.
All right, thanks, Kevin. Are UV curable powders FDA acceptable, and can they be used for food packaging?
Huh. Okay. Yeah. That's a good question. And I think right now, as things stand, I'm talking to you as a formulator. We don't have the formulating toolkit to do an FDA application. And that being said, throughout my career, I've formulated all kinds of FDA food contact thermoset powder materials, and it requires a pretty thorough analysis of the materials that you're using. It would take some kind of background research to kind of go down that path and see what materials just in the UV world in radiation cure, which types of building blocks and what types of materials may be useful in a powder coating. I don't have an answer. I say I have a path that I would take, and it would be one of those things where you get to a point and say, this is a go or no go. It looks promising. It looks like maybe we could put these building blocks together and move forward. But the answer right now would be no. I'm not aware or familiar with UV curable formulating materials that can be used to make a food safe UV curable powder coating.
All right, thanks, Kevin. And we do have a few minutes left, and I'll wait here to see if a few more questions come in. But in the meantime, a couple of upcoming webinars. July 18th, 1 o'clock, we'll have Optimizing Plant Operations, including design considerations for growth. This will be led by ChemQuest Director Bob Kramer. And on July the 20th, we'll have Domestic and International Hazmat Transportation Regulatory Update. This will be led by Rhett Cash, who's counsel here with Government Affairs here at ACA. And the July 20th will be our last webinar for the summer, and we'll take a bit of a hiatus then and come back in September. Were you going to say something, Kevin?
Sorry, I'm sorry, I stepped on you. I thought you were done. There is a question, and I like this one. It said assembled semi-trailer. And I think the question is, can you powder coat an assembled semi-trailer? And I'll tell you what, I only have a couple minutes because I don't want to keep people because I'm sure they got another Zoom meeting or something coming up. But I had a project in the 90s. It was robotic cure, UV curable powder coatings, and the project